Hello, my little mathematicians. Today, we're going to work on the final study guide number 2. As always, please feel free to pause the video, try the numbers yourselves, and then once you think you got it, unpause it, come back, and check yourself. And you can pause, fast forward, rewind, whatever you want. I know that sometimes on some of the finals you can use calculators for different sections, but imagine that all of it is non-calculator. And yes, even with the long division, because in the future you might be asked to do long division by hand and you won't be allowed to use a calculator. Even in algebra, you have to do it with things with expressions and x's, and so it's the practice of long division, and you can't type that into a calculator. So please, let's at least try it, and then you can use a calculator to check yourself or the video to check yourself, okay? So when you're dividing, whatever's on top goes inside the house, and whatever's on the bottom goes outside the house. I remember in and out, in and out. That's what a hamburger is all about. So inside the house, outside the house, or top dog goes in the house. If you were to type it into a calculator, whatever's on top divided by whatever's on the bottom. Now, if you're doing this by hand, you can't divide with decimals. So in order to get rid of the decimals here, I can just move it 2 places. And however many times you move it in the divisor, you move it the same number of times in the dividend. So since I moved it 2 times here, I'm going to move it 2 times there and put a 0 placement holder. Okay, so now you have, I like to rewrite it, 504 into 170. Can 504 go into 1? No. Can 504 go into 17? No. Can 504 go into 170? No. So then what we do is we add a decimal and a 0. Now 504 can go into 1,700. I don't know about you, but I don't know my 500 times tables. So I just look at this first part, the 5. How many times does 5 go into 17? 3 times, right? So let's try 504 times 3. That's 12. Carry the 1. That's 0 plus 1. 3 times 5 is 15. Now, if this is too big, then I do 504 times 2. But luckily, that works. Okay, subtract. You can't take 2 from nothing. So go next door and borrow. And there was really nothing there, so borrow again. There we go. Okay, 10 minus 2 is 8. 9 minus 1 is 8. And 6 minus 5 is 1. And 1 minus 1 is 0. This number always has to be less than what you're dividing by. It is 188 is less than 504. So let's keep going and bring down the next 0. Okay, again, I don't know my 500 times tables, so just focus. 5 goes into 18 how many times? 3 times. And yep, that's going to be small enough so I can subtract. I can't take 2 from nothing, so borrow. 10 minus 2 is 8. 7 minus 1 is 6. 8 minus 5 is 3, and 1 minus 1 is nothing. Okay. 5 goes into 36 7 times. Let's see if that's too big. So that's 28. 0 plus 2, and 7 times 5 is 35. That works. You needed to always bring something down, right? So I need to put a 0 placement holder there. So now you have 3, 5, 2, 8. And you can't take 8 from nothing. So borrow. 10 minus 8 is 2. 7 minus 2 is 5. 6 minus 5 is 1. And 3 minus 3 is 0. Is that less than what you were dividing by? Yes. So bring down another 0. And you're like, oh my gosh, is this ever going to end? Okay. So far we did a 3 in, right? Then we did another 3, and then we did a 7. Now we're on to this one we just brought down. What's going to go here? When it starts going out like more than 3 numbers, always double check your directions and see, did it tell me to round? And in this one, it actually did. It said, please round to the nearest hundredth spot. Well, where's the hundredth spot? It's 2 numbers after the decimal, right? So go 1 number past however far it asks you to round, and that's this number right here. So this 7 tells this 3 to stay a 3 or to go up. Well, if this number is 4 or below, then it tells this one to stay. If this number is 5 or above, it tells this one to go up. So the 7 tells the 3 to go up. So if we round this number off to the hundredths place, it's 0.34. Okay, let's go ahead and try number 2. Number 2 is 9.8 divided by 9.05. So let's go ahead and move the decimal twice. So move it twice here. Now you have 905 into 980. Can 905 go into 9? No. Can it go into 98? No. Can it go into 980? Yes. How many times? Once. So 1 times 905 is 905. Then, when you go to subtract, you can't take 5 from nothing. So borrow. 10 minus 5 is 5. 7 minus 0 is 7. And 9 minus 9 is nothing. This is less than what I was dividing by, so we're good to bring the next number down. There is nothing else to bring down. So add a decimal and a 0. Now I can bring that down. 905 can go into 750, or can it? It can't, right? So instead of just bringing another number down, you can't bring 2 numbers down back to back. So I need to put, it goes, 905 goes into this 0 times. So 0 times 905 is 0. Subtract that, you get 750. Now you can bring another number down. You couldn't bring them like back to back without doing anything here, but now I can move on to the next number. Okay, and 905 can go into 7,500. How many times? Well, how many times does 9 go into 75? 8 times, right? Let's see if it's too big. That's 40. 0 plus 4, and 9 times 8 is 72. Perfect, that works. Okay, when I go to subtract, that's 0. I can't, so borrow. 10 minus 4 is 6. 4 minus 2 is 2. 7 minus 7 is 0. This is less than what I divided by, so I'm good to keep going. And I'd multiplied by 8 to get that number, right? Okay. Can I stop? No, it said I had to round it to the hundredths. So I need to go at least one number further than the hundredths. So this will be my last one. How many times does 9 go into 25? Well, 9 times 3 is, by 25, I totally meant 26. 9 times 3 is 27. That's too big. So 9 times 2 is 18. Let's see what that gets. 905 times 2 is 10. That's 0 plus 1. 9 times 2 is 18. Okay, so I can subtract that from 2,600. That's 0. I can't, so borrow. 10 minus 1 is 9. I can't take 8 from 5, so borrow. 15 minus 8 is 7. 1 minus 1 is 0. This is less than what I divided by, so I'm good to go when I multiplied it by 2. Okay. Remember it said to round to the hundredths place, so I needed to go one number further than that. If the number behind the one you're focusing on is 4 or below, it stays. If the number behind it is 5 or above, it'll go up 1. It falls into the 4 or below category because it's a 2, so that stays an 8. So my answer is 1.08 rounded to the hundredths place. All right, for my next one, number 3. It says 1.1 divided by 4.6. I can't divide with decimals, so move it over here, and you have 46 into 11. Can 46 go into 1? No. Into 11? No. So add a decimal and a 0. Now 46 can go into 110 how many times? Well, 4 goes into 11 how many times? 2 times, right? So let's try 46 times 2. That's 12. 8 plus 1 is 9. That works. So that times 2 is 92. When you subtract, you can't take 2 from 0, so borrow. And 10 minus 2 is 8. And you can't take 9 from 0, so borrow. And 10 minus 9 is 1, so you get 18. Okay, 18 is less than 46, so I'm good to bring the next number down. How many times does 4 go into 18? 4 times, right? So let's try, because 4 times 4 is 16. So 4 times 4, let's see if that'll work. 24, that's 16 plus 2 is 18. Oof, it's just slightly too big. So I need to try one less. That's 18, 12, 13. Okay, that works if I had multiplied it by 3. So that can't take away, so borrow. 10 minus 8 is 2, 7 minus 3 is 4, 1 minus 1 is 0. This is less, so I'm good to keep going. All right, and then for the next one, let's try 4 goes into 42. Well, 4 times 10 is 40, and I can't do a 2-digit, so let's try 46 times 9. That's 54, 36, 37, 38, 39, 40, 41. And that works if I'd multiplied it by 9. Okay, and regardless of what I get, I know that, and actually if you do it really quickly, you get 6, which is less than this, so I know it's good. Right here, when I go to round it off, this 9 tells the 3 to stay or go up. Go up. So my answer would be 0.24. Okay, if you haven't tried any long division yourself yet, please do so for this next one. Okay, so for number 4 is 35.4 divided by 19.1. You can't divide with decimals, so move it. And since I moved it once there, let's move it once there as well. 191 into 354. 191 can't go into 3. It can't go into 35, but it can go into 354. How many times? What do you think? Well, 1 goes into 3 times. I can already tell kind of when I multiply it, it's going to be slightly bigger though. So let's try times 2. And if you don't believe me, 27, that would be 3, 4, 5. See? And if you try times 2, 18 plus 1, 2 plus 1 is 3. Even that's too big. So it's going to go in once. All right, subtract, that's 3. You can't, so borrow. 15 minus 9 is 6. And 2 minus 1 is 1. That's less than what I divided by. So I'm good to keep going, but there's nothing. So add a decimal and a 0. Bring the 0 down. Okay, what do you think? Let's try 8. What's 191 times 8? That's 8. 72. 8 plus 7 is 15. All right, that worked. If I'd multiplied it by 8. You can't take 8 from nothing, so borrow. 10 minus 8 is 2. 2 minus 2 is 0. 6 minus 5 is 1. This is less than what I divided by, so I'm good. I don't need to erase and try again. I need to keep going. Okay, so this one, 8 was too big by quite a bit. So 7 definitely wouldn't work. That was bigger by a lot. Let's try times 5. 191 times 5. So if we get 5, and then that's 45. 5 plus 4 is 9. So we get 955 if we had multiplied it by 5. When we go to subtract, 5 can't be taken from 0, so borrow. 10 minus 5 is 5. 5 can't be taken from 1, so borrow. And since there was nothing there, I need to borrow again. 11 minus 5 is 6. 9 minus 9 is 0. And that's 0. So it's just 65. Okay, good to keep going. And let's see, probably 3 or 4. Let's see what 191 times 4 is. 436. 4 plus 3 is 7. That's too big, so it's times 3. 573. And when you go to borrow, 10 minus 3 is 7. You can't, so borrow. 14 minus 7 is 7. There you go. That's less than it, so that would work. I should keep going, but luckily, thank goodness, it said to round it to the 100th. That 3 tells this 5 to stay a 5. So you get 1.85. Again, if you find yourself doing long division and going out more than 3 places, please look at the directions and see if it tells you to round it off or not. All right, let's take a look at number 5. Okay, number 5 says you have 3 2/3 divided by 4 9/10. When you're dividing with fractions, you have to change the mixed numbers to impropers. So keep the denominator the same, multiply the denominator with the whole number, and add the numerator in order to figure out this. So 3 times 3 is 9. 9 plus 2 is 11. This one stays the same in the denominator, and then 10 times 4 is 40. 40 plus 9 is 49. Okay, now you can't divide with fractions. We can only multiply. So I need to do keep, change, flip. So I keep the first fraction the same. I change division to multiplication, and then I flip that second fraction. Now that we have it set up like this, I look to see if anything can cross cancel. Can anything go into both 11 and 49? No. Can anything go into 3 and 10? No. So now I just multiply across. 11 times 10 is 110. And 49 times 3, that's 12 plus 2 is 14. Okay, if it was improper, I would need to change it, but that's not improper, and we know it can't reduce, so we're good to go. Okay, I'm going to change colors just because this is all starting to blur together. Number 6, you have 1/2 divided by 3/8. Again, we can't divide with fractions, so I'm going to instead change it to a multiplication problem by going keep, change, flip. Keep the first fraction the same. Change division to multiplication and flip that second fraction. Have it be the reciprocal. What was on top goes to the bottom, and what was on bottom goes to the top. Now look to see if anything can cross cancel. Yes, 2 can go in to both 2 and 8. 8 divided by 2 is 4, and 2 divided by 2 is 1. Now when you go to multiply across, 1 times 4 is 4. 1 times 3 is 3. Can you leave it like that? No, because it's improper. So you take the top and divide it by the bottom. 3 goes into 4 once. 1 times 3 is 3. Subtract that, you get 1. And so you put your remainder over what you divided by, which means 4/3 is the same thing as 1 1/3. Okay, number 7. 5 9/10 divided by 1/2. If you haven't tried one of these yet by yourself, why not pause it and try this one? Okay, so again, we want to change this mixed number to an improper. Keep it the same. And then to get your numerator, this times this plus this. So 50 plus 9 is 59. Divided by 1/2. Keep, change, flip. All right, and can anything cross cancel? Yeah, 2 can go into both 2 and 10. So 10 divided by 2 is 5, and 2 divided by 2 is 1. These can't cross cancel, so just multiply across. 59 times 1 is 59, and 5 times 1 is 5. That's improper, so I need to change it by taking the top divided by the bottom. 5 goes into 5 once, the remainder of 0. Bring down the 9. 5 goes into 9 once. Subtract, you get 4. So you put your remainder over what you divided by. So 59 over 5 is the same thing as 11 4/5. Okay. Number 8, same type of problem. 7 1/8 divided by 5/4. Okay, if you haven't gotten one of them right yet, this is it. I can feel it. Change this mixed number to an improper. 8 times 7 is 56. 56 plus 1 is 57. Divided by 5 over 4. We can't do division of fractions, so I need to change it to a multiplication problem. So keep the first one the same. Change division to multiplication and flip that second fraction. Do you see anything that can cross cancel? Yes. 4 and 8 are both divisible by 4. If you saw that it was only 2, then you just would have had to reduce it again. 4 divided by 4 is 1, and 8 divided by 4 is 2. Multiply across. 57 times 1 is 57, and 2 times 5 is 10. That's improper, so take the top, divide it by the bottom. 10 goes into 57 5 times. And when you subtract that, you get 7, so you put your remainder over what you divided by. So 57 over 10 is the same thing as 5 7/10. All right, now on to the fun stuff. The GCF and LCM. So for number 9, both sections 9 through 13, when you do GCF and LCM, I suggest doing the ladder method. So that's where you do this, and you have the two numbers of 50 and 20. What number can go into both 50 and 20? They're even, so 2 can. 2 goes into 50 how many times? 25. 2 goes into 20 how many times? 10. Now, can anything go into 25 and 10? Yeah, 5 can. 5 goes into 25 5 times. 5 goes into 10 2 times. Can anything go into 5 and 2? No. So we're done. 2 times 5 is 10. So your GCF would be 10. Now, some people are like, oh my gosh, I missed it because mine looks different. You could have chosen to start with 5 and done 5 times 10 and 5 times 4 and then done 2. And you still end with 5 times 2, which is 10. Or some people right off the bat saw, oh, hey, they both end in 0, so 10 can go in. It goes in 5 times. It goes into that 2 times. And they just have a shorter ladder. So the bigger number you choose, sometimes the shorter your ladder is. It's okay. You'll still end up ending with 5 and 2 here. And when you multiply the numbers along the side, you'll get a GCF of 10. Okay, so again, if your tree or your ladder looks a little different than mine, it's okay. We still should end with the same answer. Number 10, why don't you guys try it yourself? Pause it and then come back. Okay, so now that you're back with me, even if you start different, it's okay. We should still end the same. I look at this and I immediately see 4. So 4 times 4 is 16 and 4 times 12 is 48. And then I see 4 can go into those. That goes in once. And 4 times 3 is 12. So I can't keep going. 4 times 4 is 16. A lot of you guys probably started with 8. Because you're like, 8 goes into 16 twice, and 8 times 6 is 48. And then you would go 2. 2 times 1 is 2, and 2 times 3 is 6. You still would have gotten 8 times 2 is 16. Okay, finally for this section, 11, you have 34 and 30. What can go into both? Well, they're both even, so you know that 2 can go in. And 2 goes into 34 17 times. If you need to, you could have done some long division. And 2 goes into 30 15 times. Can anything go into 17 and 15? No. So 2 is your GCF. That's it. Now for my next section, the LCM, it starts off the same. There's just a small difference. You'll see. Okay, 36 and 27, I'm still going to make a ladder. What can go into both? 3 can. 3 times what is 36? 12. 3 times what is 27? 9. Can anything go into 12 and 9? Yeah. 3 can. 3 times what is 12? 4. 3 times what is 9? 3. Now, some of you guys are thinking, Miss Love, you made a mistake. We moved sections. We're now doing LCM, not GCF anymore. I know, but it still starts the same. The only thing that's different is if they asked for GCF, I'd say, oh, it's 3 times 3, it's 9. But instead, since they asked for LCM, I do all the numbers along the outside that kind of almost make an L shape, L for LCM, and I multiply those. So again, if they ask for GCF, it's just these ones along the side. If they ask for LCM, it's all the ones here that make the total L. 3 times 3 is 9, 4 times 3 is 12, and 9 times 12 is 108, which means the smallest number that both 36 and 27 can multiply to become is 108. The GCF is 9. 9 is the greatest number that can go into both 36 and 27, but the smallest number, LCM, that they can both multiply to become is 108. Okay, and that's the difference between those two things. So why don't you guys try 14? And by 14, I meant 13, because that's the next problem. Number 13 is 35 and 14. Okay, what can go into both? 7. 7 times what is 35? 5. And 7 times what is 14? 2. Can anything go into 5 and 2? No. So I'm done. Go ahead and multiply all the things along the outside. 7 times 5 times 2. Now, if you go 7 times 5 is 35 and 35 times 2, you're like, ugh, that's hard. Sometimes you can go the other way because 2 times 3 and 3 times 2 is the same thing, right? It doesn't matter if you flip them. Commutative property. So let's start this way. 2 times 5 is 10. 10 times 7 is 70. Well, that's easier. Okay, if you start going this way and it's too hard, then go this way. 7 times 5 is 35. 35 times 2, ew, I don't know. So then do 2 times 5 is 10. 10 times 7 is 70. So the smallest number that both 35 and 14 can multiply to become is 70. Okay, 14. Try that one yourself. You got this. 20 and 35. What can go into both? 5 can. 5 times what is 20? 4. 5 times what is 35? 7. Can anything go into both 4 and 7? No. So multiply 5 times 4 times 7. Well, 5 times 4 is 20. So 20 times 7. Well, 2 times 7 is 14. Tack on that 0. You get 140. All right. New section. Number 15 says, Heather was planning a trip to Argentina. I was, huh? Before going, she did some research and learned that the exchange rate is 19 pesos to $6. How many pesos would she get if she exchanged $12? So this kind of sounds like a proportion problem to me because they gave me 2 pieces of information and then they gave me a third piece of information asking me to find the fourth. So number 15 is talking about pesos and then like our American dollars. And they say the exchange rate is 19 pesos equals 6 of our dollars. So then I want to know, okay, if I give them $12, where should I put that? $12. I should put that on the bottom because that's where dollars are. How many pesos is that going to be? Okay, you can always do cross products where you go 6 times x equals 19 is across from 12. And you would multiply that out. 19 times 12 is 228. And then to get x by itself, you would divide both sides by 6. And 228 divided by 6 is 38. So you'd get 38 pesos. But sometimes there's a nice little shortcut. Can you go from 6 to 12? Yes, you can. But sometimes you don't know if it's like, wait, do I multiply by 2 or do I divide by 2? Which way does it go? Always move towards the direction of where your x is. So since my x is here, move towards it. So this one goes this way. How do you go from 6 to 12? I multiply by 2. So multiply this by 2. 19 times 2 is 38. So regardless of if I used cross products, this times this, that equal to this times this, or if I used my shortcut, I still get 38 pesos is what 12 American dollars is equal to. This way always works. This way only sometimes works. If you can go from here to here, then great. I can use the shortcut. Okay, problem 16. Says the currency in Switzerland is the franc. The exchange rate is approximately $3 for every 4 francs. At this rate, how many dollars would you get if you exchanged 20 francs? So I'm talking about francs to dollars. And they say that 4 francs is $3. Normally, like the first part that goes together that's going to make your first proportion is like within one sentence or before a comma. And then after that comma or after that period is your third piece of information. And you need to figure out where it goes. Well, it says 20 what? 20 francs. Where francs go? On the top. And then we don't know how many dollars that is. So dollars is the X. Okay. This is the direction towards where my X is. Can you go from 4 to 20? Yes, you can if you just multiply by 5. So do 3 times 5 and you get 15. So 20 francs is equal to 15 bucks. Okay, our next one says if you can buy 1 can of pineapple chunks for $2, then how many can you buy with 10? What are we talking about? We're talking about money and how many cans of pineapples you can buy. Hopefully none, because pineapple's gross. Just kidding, at least in my opinion. Okay, so you have $2 for what? For 1 can of pineapple. Now, how many cans can you buy with $10? So 10. What's 10 talking about? It's $10. Where dollars? We put it on top. And then we don't know how many cans we can buy with that. So I'm going to go ahead and move towards the direction of my X. Can you go 2 times something to get 10? Yes, 2 times 5. So go 1 times 5 and you get 5. So I can get 5 cans for that much. All right, number 18, moving right along. Says the money used in Oman is called the rial. The exchange rate for the 4 rials is every $10. Find how many rials you would receive if you exchange $40. So we have rials to our money. And it says 4 of that is equal to 10 of our dollars. So find how many rials, so we don't know how many rials, is equal to 40 of our dollars. Okay, there's where the X is. So move towards that. Can you go from 10 to 40? Yes, you can if you do 10 times 4. So do 4 times 4 and you get 16. So 40 bucks is equal to 16 rials. And always double check, is that what they were looking for? Yeah, they were looking for how many rials. And so that's where my unknown was. The unit was rials. Okay, number 19, moving right along. Shauna is at the store comparing 2 brands of juice. Brand A costs $3.84 for a 16-ounce bottle. And the other one is $4.50 for a 25-ounce bottle. Which is the better buy, brand A or brand B? Okay, what we want to do is, first of all, we want to find the unit rate. How much is it for just 1 ounce? So how do I figure that out? Divide whatever's in the denominator, because anything divided by itself is 1. And then do the same thing on top. I know that we already did long division at the beginning, so let's just assume you know it. Type it into your calculator. What's 3.84 divided by 16? You get 24 cents. Okay, so this is 24 cents an ounce. How much is this one per ounce? What should I divide by? 25, because that's what's in the denominator. So 25 divided by 25 is 1. And what's 450 divided by 25? 18 cents. So what's the better buy, 24 cents or 18 cents? 18 cents is cheaper, so brand B is the better buy. You want to spend less money, right? Okay, number 20 says Mason's favorite brand of peanut butter is available in 2 sizes. The regular size is 16 ounces and sells for $3.36. The family size is 40 ounces and sells for $7.60. Which is the better buy, the regular or the family? So we have the regular, which is $3.36 for 16 ounces. And then the family, which is $7.60 for 40 ounces. So if I want to find the unit rate, I'm going to divide both of these by 16 and divide both of these by 40. So 336 divided by 16 is 21 cents. And then here, 760 divided by 40 is 19 cents. Which is the better buy? 19 cents is the better buy. So we want to go with the family one. Okay, and finally, I'm going to use the paper for this one. It says draw a graph for each inequality. So it's x is greater than or equal to 3. So at 3, I'm going to draw a circle. Should I shade it in? Yes, because there's a line underneath. It's including that point. And then the great big open end is facing it. So where do numbers get bigger? To the right. Okay. Notice when the variable's on the left, this inequality sign matches your arrowhead, right? See how that matches this? Okay, this one, if I want to use the arrowhead trick, maybe I want to switch the n and the 5. And then since I switched where they are, flip the direction of the inequality sign. So now at 5, I'm going to draw a circle. Is it open or closed? Open, because there's no line underneath. And what's facing my n? The little tiny end. So numbers get smaller to the left. And again, since I redid it, here this is facing towards the left. All right, my little mathematicians, I hope you did well on the first side. Join me for the second video for the back side.